comes the creation of the training and the testing data. Okay. Of course, we are making the model. The training and test data set will be there. Training set is what? For building the model. Okay. And test data set for examining its predictivity. Okay. How it is, whether it is, what is the ability to predict of this particular model, that is for your test data set. Okay. Now comes the variable selection. As I told you, there is no variation in your data. That data will not be considered. Okay. Now here the variable selection will be there. There are hundreds of molecular descriptors available for building a QSAR model. Okay. But not all the molecular descriptors are important in determining the biological activity. So to find the optimal subset of the descriptor which plays an important role in determining the activity, okay, that variable selection method is required. Okay. This variable selection further divided into the two categories. See, whatever here I'm describing, I'm discussing, all these things are done with the tools, with the software, with the resources. Okay. Here you just have to understand how the things are working. Okay. So this variable selection, either you go for the systematic variable selection or the stochastic variable selection. Systematic variable selection, that means they will add or delete the descriptor in step one by one in a model. They will add this descriptor, see the performance, delete this descriptor, see the performance. That is what your systematic variable selection. The second one is the stochastic selection. Okay, in the that is widely used basically. Okay. So these methods are based on the simulation of the physical and the biological process. Okay. These methods basically create the model by randomly, generating the model, and they further modify the model by using the different operators. Okay. For the example of the stochastic, the genetic algorithm we use, that again, in the tool you will get it. So that is the stochastic variable selection. That these are two ways basically to select the variable. Now we have created the model. Okay. Model creation is what? That we have identified the correlation, okay, between the dependent variable and the independent variable. Okay. Dependent variable is what? The biological activity. Independent variable is what? Molecular descriptor. Okay. So once the model is created, we need to evaluate it as well. Okay. Before using it, we have to evaluate the model. And to evaluate the model, the cross validation is there. Okay. The cross validation method is used to evaluate the model basically. So here what the leave one out cross validation method is there, which is widely used. It is not the only method. One more thing. Okay. So what happened? Each data value is left out in turn and a model is derived using the remainder data. One single value will be removed. Okay. And whatever the remaining data is there, what will happen? We will check whether the model is correct or not. Okay. Once the model is evaluated, we have to interpret it. Okay. We have to interpret
Sorry for interruption, Dr. Jyoti.
Sure.
Some people have some doubt. Please clarify that in chat. They are asking that EH is dependent and independent variable. Please repeat.
Yeah. EH is dependent. What is? Okay. What is dependent and what? Okay, sorry. Okay. When we talk about the dependent and independent is basically while working on the model, while working on the machine learning, what we have to work on, your compound is there. Okay. What your molecular structure will be there, and the molecular structure, many things are there, which we are known as the molecular descriptors. Okay. And what we are looking for the activity of the compounds. Okay. So what we have to look for on the basis of these descriptors, is the activity somehow dependent? Okay. On the basis of these descriptors only, the activity will be dependent. As I told you, not all the hydrophobic compounds are the anesthetic inhalation, right? That hydrophobicity is the one property of the compounds, but all the hydrophobic compounds are not responsible for that. Now, next, what we are looking for? We are looking for further properties, further features. Okay. So all these further features are like your biological activity is dependent on these features. right? Only then we will be saying, now, okay, if these features are there, only then this compound is the inhibitor of the protein, right? That means your biological activity is dependent upon the features of these compounds. But the features of these compound are not dependent on the biological activity, right? They possess the features, and these feature, on the basis of these features, the compound is defined whether it is, inhibiting or activating the compound or not. Is that clear? That means the activity of the compound is depend upon the descriptors of the compound, the molecular descriptor, you can say the features of the compounds, right? Okay, I hope it is clear. Okay. Next, the model interpretation will be there. Okay. So, as I told you in the beginning, it uses the statistical methodology, the multiple regression, the PCA thing, all these things it uses. Okay. So, this multiple regression, which we widely use for the, QSCR model. Okay. So, it is just to interpret the regression model. So, in basically what happened in contribution of the each descriptor could be seen what, like how it is responsible for the activity. That is what your regression. For each descriptor, it will see which descriptor is more actively involved in the activity of the compound. Okay. That linear relationship will be seen in the multiple regression method. That is for the model interpretation. And then further we can apply the QSAR. What is the application of QSAR? Basically, how we can apply the QSAR. Now you are having a model. You must know that in this model, these are the compounds which are well known for the activity of this particular, whatever. For example, they are responsible for the inhibition of the protein A. Now, next, whatever the compound will be there, you will see, you will check the compound in your model and you will see whether it is a good fit or not. And you, at that stage only, you will whether accept it or delete it from the further research. All right. That is the benefit of the QSAR. Okay.